In August of 2022, an entire Chinese province had to make a choice that most of us will hopefully never have to think about, which was whether to keep the factories running or keep the air conditioners on. Sichuan, home to more than 80 million people, was in the middle of what officials called the worst heat wave in 6 decades, with Chengdu and the surrounding cities sitting above 40 degrees Celsius for days on end, and the province gets roughly 80% of its power from hydropower, which meant the same heat driving everyone's air conditioning demand through the roof was simultaneously drying up the rivers that were supposed to be generating the electricity for it. Something had to give. And the government's answer was to shut down factories across 19 of the province's 21 cities for 6 straight days, just so ordinary households could keep their AC running through the worst of it. Malls and office towers were told to push their thermostats up to 26 degrees, turn off elevators below the 3rd floor, and cut their lighting to a third of normal. Shanghai, 1,000 kilometers away, switched off the decorative lights along the Bund, one of the most photographed skylines in the world, just to shave a sliver of demand off a grid that was buckling under the weight of 100 million air conditioners running at the exact same time. That's the moment many Chinese engineers point to when explaining why cities can't rely on cooling the way they always have. The real problem with air conditioning isn't comfort, it's timing. Millions of units switch on during the hottest hours, all pulling electricity from the same grid when demand is at its peak. Building new power plants just to handle those few weeks each year is expensive and inefficient. So instead of asking how to generate more electricity, some Chinese cities asked a different question. What if every building didn't need its own air conditioner? The answers range from paint that cools buildings to giant underground systems that make ice at night. And by the end of this video, you'll see how these ideas work together to rethink cooling from the ground up. Mist cooling, taking the fight outside. The first piece is the one that's easiest to picture because it's the one that went viral. In several residential communities across China, you'll now find towers and public courtyards fitted with a system some people online started calling the outdoor AC, even though it has nothing to do with a conventional air conditioner at all. There's no refrigerant, compressor, or unit humming on the side of a building. What you actually see is a fine mist releasing from nozzles mounted along walkways and building exteriors, a mist so light it looks almost like fog rolling through a courtyard. And the science behind it is something we've technically understood for a very long time, which is evaporative cooling. Water absorbs heat as it evaporates, and if you can get a mist fine enough that it evaporates before it ever really lands on anyone, you pull heat out of the surrounding air without leaving people soaked. Reports on these residential systems put the temperature drop at somewhere between 3 and 6 degrees Celsius during activation, which doesn't sound dramatic until you're the one standing in a courtyard during a heat wave, and that's the difference between miserable and tolerable. The same principle shows up in a slightly different form out in Turpin, one of the hottest places in the entire country, where summer temperatures regularly climb into territory that would be dangerous for anyone spending real time outdoors. Turpin has installed misting equipment across public spaces, and according to CGTN's coverage of the system, it's capable of dropping localized temperatures by 3 to 8 degrees Celsius, while also cutting down on dust and adding a bit of humidity back into what is otherwise brutally dry desert air. And this is really the part to think about, because a home air conditioner has never been able to do anything for the person waiting at a bus stop or walking through a market or standing in a public square. Conventional AC only ever cooled the inside of a box. It never had an answer for the street. Mist cooling does, and that's a genuinely different way of thinking about what a cooling system is even supposed to do. It's also aimed intentionally, showing up in squares, sidewalks, bus stops, and tourist corridors, the exact spots where someone has no building to duck into, rather than being scattered evenly across an entire city. District cooling. One plant, an entire district. Mist cooling handles the street, but the bigger shift, the one that's actually reshaping how Chinese cities are built, is something called district cooling, and the concept is almost deceptively simple once you understand it. Instead of every building in a district running its own separate air conditioning system, each with its own compressor, its own energy draw, its own maintenance costs, a single centralized plant produces chilled water and pushes it out through a network of underground pipes to every building connected to that network. The water absorbs heat as it moves through each building, gets sent back to the central plant to be rechilled, and the cycle repeats. It's the same basic logic as district heating systems that have existed in northern cities for a long time. Just flipped cold water traveling through pipes instead of hot water, and the building never needs its own cooling equipment at all. The clearest example of this working at real scale is in Shenzhen, specifically in the Qianhai Qianhai Cooperation Zone, where what's being built is one of the largest district cooling networks anywhere in the world. The numbers here aren't small. The Qianhai No. 5 cold station alone, currently the largest cooling station in Asia, has a total capacity of 38,400 refrigeration tons and serves roughly 2.75 million square meters of buildings. And that's just one station out of 10 that are planned across the zone. Once the full network is complete, the plan is for those 10 stations to cover around 19 million square meters through a pipeline network stretching about 90 kilometers underground, delivering a combined cooling capacity of 400,000 refrigeration tons. To put that into perspective, that's an entire district's worth of offices, shopping centers, and transit stations, all being cooled from a handful of central plants instead of thousands of individual units scattered across thousands of individual buildings. There's also a business model question underneath this that rarely gets talked about, which is that Qianhai's district authorities own the plant buildings and the pipe network itself, while a separate energy company owns and operates the equipment inside, treating cooling less like a private amenity bundled with a building and more like a public utility. A building simply connects to the same way it connects to the water main. Ice thermal storage, making ice at night to stay cool during the day. All right, here's the part of the district cooling story that deserves its own spotlight, because on its own, it's the single most counterintuitive idea in this entire video. The plants at Qianhai use something called ice thermal storage, and the plain version of what that means is that these cities are making ice at night specifically so they can stay cool during the day. Here's how it actually works. Overnight, when electricity demand across the grid is low and prices are cheaper, the plant runs its chillers to freeze large volumes of water into ice and stores that ice in massive tanks. Then, during the day, when the heat peaks and every air conditioner in the city would normally be straining the grid at exactly the same time, the plant uses that stored ice to produce chilled water without needing to run its chillers at full power during the hottest, most expensive, most grid-stressing hours of the afternoon. It's a way of moving the actual energy cost of cooling a city from the moment everything is under pressure to the middle of the night, when the grid has room to spare. Shenzhen even set a specific ice storage electricity rate, around 0.28 yuan per kilowatt hour, specifically to make that kind of overnight production worthwhile, according to Asian Development Bank documentation on the project. That's the detail that tends to get missed when people describe this as just big air conditioning. It's not just big, it's timed differently, and that timing is the entire reason it works. Once the full Qianhai network is operational, the projected savings are around 130 million kilowatt hours of electricity every year compared to what the same buildings would use running individual air conditioning systems, along with roughly 130,000 tons of carbon dioxide emissions avoided annually. Passive cooling architecture, the oldest trick in the book. Everything so far has been modern engineering, pipes, plants, mist nozzles. But some of the most effective cooling in Chinese cities right now isn't new technology at all. It's a few hundred years old, and it's making a serious comeback. In southern and eastern China, traditional homes have long featured something called a sky well, known in Mandarin as tianjing, which is a small rectangular courtyard built into the center of a house enclosed on most sides by the surrounding rooms. It dates back at least to the Ming dynasty, and the design does something clever with airflow. As warm air inside the house rises and escapes through the open sky well, it pulls cooler air in behind it, creating a constant vertical current of ventilation without any electricity involved at all. Some traditional sky well homes in southern China have been measured running as much as 4.3 degrees Celsius cooler inside than the outdoor temperature, purely from that airflow effect. What makes this genuinely interesting for a modern audience is that architects are now deliberately borrowing the idea for brand new buildings. The National Heavy Vehicle Engineering Technology Research Center in Jinan built an 18-story tower with a massive open void running from the 5th floor all the way to the top, using the exact same rising air principle as a traditional skywell to ventilate the whole building. The Dongguan-Ti BA Tower in Guangdong Province, a 68-story building, takes the concept even further. Using internal air channels its designers call windpipes to carry natural airflow to every single floor without a courtyard at all. It's a rare case of a centuries-old idea developed by people who had never heard the word thermodynamics, getting revived by engineers working on some of the tallest buildings in the country, not out of nostalgia, but because the physics still works exactly as well as it always did. Radiative cooling paint, sending heat into space. If the skywell is the oldest idea on this list, this next one might be the strangest, because it sounds like something out of science fiction, and it isn't. Radiative cooling paint works by taking advantage of a very specific gap in our atmosphere. Most heat that radiates off a hot surface gets trapped by the atmosphere and bounced back down toward the Earth, which is part of why cities stay hot even after the sun goes down. But there's a narrow band of infrared wavelengths, roughly between 8 and 13 micrometers, that the atmosphere doesn't absorb at all. Heat radiating at those specific wavelengths passes straight through the sky and out into space, essentially for free. Coatings engineered to emit heat specifically within that band while also reflecting the vast majority of incoming sunlight can stay cooler than the surrounding air even while sitting in direct sunlight, without consuming a single watt of electricity to do it. This isn't just a lab experiment either. AkzoNobel launched a radiative cooling coating system in China built specifically around this principle, using a reflective top coat paired with a thermal radiation barrier layer, and reported that it can lower a building's surface temperature by up to 10% compared to conventional coatings during the hottest months of summer. Think about that for a second. A can of paint that quite literally uses outer space as somewhere to dump a building's excess heat. It's the kind of detail that sounds made up until you realize the physics behind it has been understood since the 1960s, and it's only in the last few years that anyone's figured out how to put it in a bucket and sell it. Cool pavements, fixing the ground itself. There's one more surface in a city that almost never gets talked about in this conversation, and it might be the largest one of all, which is the pavement under everyone's feet. Roads, sidewalks, and parking lots typically make up somewhere around a third of a city's total surface area, and dark asphalt absorbs somewhere between 80 and 95% of the sunlight that hits it, which means it doesn't just get hot, it becomes a kind of battery that keeps radiating stored heat back into the surrounding air long after sunset. That's a huge part of what's known as the urban heat island effect, where a dense city can run measurably hotter than the countryside just 20 or 30 kilometers away, purely because of what its surfaces are made of. Chinese researchers have been especially active in tackling this specific piece of the problem, testing heat-reflective coatings that can be applied directly onto existing asphalt to raise its reflectivity without needing to tear up and replace the road itself. And studies looking at cool roof applications in cities like Chongqing, Shanghai, Wuhan, and Guangzhou have found measurable reductions in surface temperature during heat wave conditions. The mechanism is almost embarrassingly simple. Lighter colored, more reflective surfaces bounce sunlight away instead of absorbing it, which means less heat gets stored in the pavement during the day and less heat gets released back into the air once night falls. It won't get you a headline the way a giant underground cooling network does, but multiply that small temperature reduction across a third of a city's entire surface area, and it adds up to something real. Personal cooling technology, the version you can actually wear. Everything up to this point has been about cooling a city, a district, or a building. But there's a much smaller category of this technology that's worth ending on, because it's the one you can actually go buy right now and strap onto yourself. China's electronics manufacturing base, especially around Shenzhen, has been turning out an entire generation of personal cooling devices built around principles that scale down the exact same physics used everywhere else on this list. Wearable neck coolers use small thermoelectric chips, sometimes called Peltier chips, that actively pump heat away from a metal plate resting against the back of the neck, capable of running dramatically below the surrounding air temperature and cooling the skin directly through contact rather than just blowing air around it. Fan-based cooling vests take the evaporative principle from mist cooling and shrink it down to the scale of a single body, circulating air across the skin to speed up the same evaporative heat loss that a fine outdoor mist relies on at city scale. If you enjoy stories like this, make sure to stick around, because China is coming up with a lot of smart ideas by solving old problems in new ways. Let me know in the comments which one surprised you the most, and I'll see you in the next video.